Okay, so this first part here we've actually done before, but this is section 6.5. I'm giving you, this is just an expression, but a polynomial expression here, and I'm asking you if these two things are factors. So first of all, I'm asking you if x plus 2 is a factor. If it's a factor, then when I do synthetic division, I should get 0 as a remainder. So I'm going to set that equal to 0 and solve. Negative 2 is going to go in my box, and then put my coefficients. Okay, then I'll go through and do my synthetic division, and we'll see what happens. Now, if you see this, we do have a remainder. What that means is x plus 2 is not a factor. Okay, let's check on the x plus 1. So set it equal to 0 and solve. Coefficients. And do my synthetic division. Okay, now you'll see I have a remainder of 0, which means x plus 1 is a factor. Now the other thing that it means is I could rewrite this that I divided into as x plus 1 times my answer down here, which is x squared plus 0x minus 16. Now let's take this right here and let's answer another question about it. Now I'm actually going to write out what I just had there. Was it x plus 1? Yes. I'm going to write out this part that I just had. Okay, so same expression, but I did make it into an equation. So I add equal to 0. Remembering that x plus 1 is a factor, which means I could rewrite that this way. What I want us to do is solve this thing. Now, I could go through and solve it if I can finish factoring, right? So let me factor this. Minus 4 plus 4. Difference of perfect squares. And then I'm going to set each of those equal to 0 and solve. So negative 1, which I pretty much already knew because I got that from the thing I put in the box. Here are my 3 zeros, my 3 roots, my 3 x-intercepts, however you want to phrase that. Now, what we're going to do today is, in this section, is we're really going to focus on getting that first number, because I gave that to you this time. I told you, well, I asked you, is x plus 1 a factor? And then when we found out it was, then we went through and found the others. The question that we need to figure out today is, how do you find that first factor which correlates to the first 0 or the first root or the first solution that we found here? So we're going to kind of take this a little bit aside for a minute and focus on finding that first one. Because once we have that first one, we can finish up by factoring. If we had to do quadratic formula here, we could have done that. But we could finish up if we can find that first one. So taking a little bit of an aside here, I want us to talk about something called the rational zero test. Sometimes, especially those of you who take pre-cal next year, that book, they call it the rational root test. So root means the same thing as 0, so Mr. Beasley might use rational root test instead of zero test. Means the same thing. Now, here is the purpose of this. The rational zero test, or the rational root test, will help us to find the first 0. From there, we probably will be able to factor quadratic formula or something like that. Okay, so just a reminder, because it has the word rational in it, a rational number is a fraction. In this particular test, we're going to make a fraction with the constant and the leading coefficient. Now, in my problem, the constant is negative 4, and the leading coefficient, is 3. What we want to do is we want to take factors of each of those. So factors of negative 4 are 1, 2, and 4. So 1 times 4 is 4, 2 times 2 is 4. Now I need a negative 4, so I think I need to pretty much put plus or minuses in here for everything, because I could have positive 1 times a negative 4, or I could have negative 1 times a positive 4. So I've got positives or negatives. Okay, factors of 3, 1, and 3. Again, I'm going to put plus and minuses in here because I could have negative 1 times negative 3, which would be a positive 3. Now, to list your possible zeros, you're just going to make a fraction out of those. So I took factors of my constant over factors of my leading coefficient. Now let's actually list these out. So I have 1 over 1, 2 over 1, 4 over 1, 1 over 3, 2 over 3, and 4 over 3. Now there's 1, 2, 3, 4, 5, 6, and really 12 because each of them has a plus and the minus. So 12 possible answers here that could be zeros. Now these zeros listed here are the rational ones. So this doesn't list anything that's either irrational, so something like square root of 7 isn't going to be on our list. It doesn't give us anything that's imaginary. If it's a rational number, it should be on this list, and it's one of your zeros. Now what we're going to do with this is we're just going to honestly have to guess and check with each of these to see which one is a zero. Now I want y'all to think about this. When I say guess and check, what we're going to go through and do is do synthetic division. If it's one of our answers, what should the remainder be? Remainder should be 0. Okay, so let's look at a problem. I was a little bit mean to you because I gave you 24 that has a lot of factors here. So let's find our list of possibilities. So I'm going to take factors of my constant and divide by factors of the leading coefficient. So factors of 24 are 1, 2, 3, 4, 6, 8, not 10, not 11, 12, and 24. Okay, so a lot of possibilities there. And then I'm going to divide by factors of the leading coefficient. My leading coefficient is 1, which means 1 divided by 1 is 1, 2 divided by 1 is 2, etc. So really, my list of possibilities are these right here, because any of those over 1 is going to be itself. Okay, so let's go through and let's try to find one that works. Okay, I'm going to just pick 1 because it's first on my list. So what I'm going to do is put it in my box, and then I'm going to go through and do synthetic division. Now, if it is one of my answers, I should get a remainder of 0. Okay, so 18. 1 is not an answer. Now, I'm not going to make you do this all day. I have cheated a little bit. I know that this one works. I'm going to tell you all it does. I'm going to do the same thing. I'm going to do synthetic division. Okay, let's see what happens. Hopefully you know what happens. There we go. There's our remainder of 0. So negative 2 checks out as an answer. Now let me write out what I have down here. X squared minus 7x plus 12. And it's still like it's set equal to 0. Now to find my other two answers, I want to solve this thing. Now it's back down to a quadratic. That's something that we know how to solve. You could solve this by doing quadratic formula or by factoring. I'm going to try factoring, honestly, just because I think it will work in this particular problem. Okay, so it factored. So when I set those equal to 0 and solve, I get 4 and 3. Okay, so here are my three answers, -2, 4, and 3. Now I want y'all to notice 3 and 4 are both on my list there. So if I had tried either of those numbers with my synthetic division, it would have worked as well. Also, when I graph this thing, and my thing isn't pulled up, so we won't necessarily graph it, but if I were to graph this thing, it would cross the x-axis at -2, at 4, and at 3. Okay, now let's do one more of these. Okay, now this time there's going to be 4 answers, okay? Alright, so factors of my constant over factors of my leading coefficient. So factors of 6 are 1, 2, 3, and 6. Factors of my leading coefficient are 1, which anything divided by 1 is itself. Okay, so that's nice of me. I didn't give y'all too many numbers here. So I'm going to guess and check until I find one that works. So I'm just going to start with 1 again. And I'm going to put my coefficients. Alright, so let's do our synthetic division. Oh, we lucked out. This is one of my answers because I have a remainder of 0. So 1 is an answer. Now, let me write out what I have here, and I'm just going to write it out on this side. I want y'all to look at the problem that we have. My problem is it's still not something that I can factor. So what I'm going to go through and do is I'm going to try to do my synthetic division again. I'm just going to pick another number on my list and try to break this down a little bit further. So I tried 1, so I'm going to try 2 next. Now what I like to do is just put a new box right here, and I'm going to put the 2 in the box and kind of mark out the remainder, and then I just use this like it's my top line. So then I don't have to rewrite them all. Alright, so synthetic division. Ooh, I think we lucked out again. Now we lucked out because we got a remainder of 0 again. If we didn't, we would need to go back and try 3 or -3, 6, -6, -2. Try one of the other numbers. 2 is one of my answers. Now let me write down, and I'll write it down over here again, what I have left. And it's like it's set equal to 0. Now, it's down to a quadratic. That's something that I can work with. I can either go through and factor this, or I can go through and I can do quadratic formula. Now again, I'm going to try to factor it because I think it will factor. So I have x equals 3, x equals 1. Now here then are my answers, 3 and 1 that I got with the factoring there, and then 1 and 2 that I got with my synthetic division here. So look at how that 1 repeated 2 times. Sometimes that'll happen. It just means that you have multiplicity of 2. Now I want you to see what it looks like on a graph. So I'm going to go through and graph this thing. So I have x to the 4th minus 7x to the 3rd plus 17x squared minus 17x plus 6. And I'm going to graph this thing. Okay, now remember, your solutions are where it crosses the x-axis. Now I can see that it's doing some crossing there. I can see it crosses there. I can't really tell what happens there. So I'm going to zoom in. I'm going to hit zoom. And I personally like zoom box just because it lets me decide how big, how much I want to zoom in. So I'm going to go through here and make a box just around the part I want to see. So I don't really care about all that up there. I only care about this, and I actually probably went further than I need to. I only care about that right there. Okay, now so my answers was 1, multiplicity of 2, it repeated 2 times, 2 and 3. I want you to see how when you have multiplicity of 2, it touches your graph and turns back around. That's true every time it has a multiplicity of 2, or really any even multiplicity. Right here at 2, when it just repeats one time, it just crosses through. Same thing here at 3. Okay, because this section's pretty long, I'm going to finish the second part in a different podcast, but this is the first part of 6.2.